Welcome back to the lab. I've got a few minutes here to go through the Boing box project, and I've been spending evenings kind of, after work and stuff like that, researching, trying to figure out what might be happening here. And the first thing I'll tell you that I discovered, if I've literally decided to go through this scientifically like I'm going through with the subwoofer. And the first thing I did was, okay, let's check to make sure I get the right kind of power coming in. Guess what? I've been plugging in a 12 volt DC supply, and I finally looked at the case, and there's a marking on the case. I'll show you a picture of that. The marking actually says 12 volts AC. So I started digging around to see if I had a 12 volt AC power supply. I do have one somewhere buried in a box, and I'm going to eventually pull that out and make that part of the lab. But ultimately, what I had was actually that one, now that I think of it, might also be DC. But ultimately, I went through all of my spare power supplies that I've acquired over the years, and one of them was a 13 volt AC. I'm hoping that 13 volts isn't going to burn it out, and so far in testing, it hasn't. Plug that in. The thing that made me suspicious about that was the fact that right here we've got a what amounts to a bridge rectifier, and I'll show you the diagram now. And on that diagram you can see bridge rectifier. Bridge rectifier is basically 4 diodes configured in such a way that it converts AC to DC. So what's coming out of the bridge rectifier is actually a DC voltage that is running then across this capacitor for filtering, and then goes through some circuitry right here to go into the 5 volt regulator. And then the 5 volt regulator carries across to the negative 5 volt regulator. And there's some confusion when I look at the circuit. I'm not exactly sure what they're trying to do, but ultimately it looks like what they're trying to do is create a positive 5 volt and a negative 5 volt rail, and not so much a ground, because I see those two voltages then coming. It's really kind of hard to see, but right in the middle here, between this capacitor and this cluster here, there's a couple of lines that work their way over. And it gets really confusing because this is a two-sided circuit board. So sometimes what they're doing, like this capacitor here, will have one connection on the back of the board, but another one that's essentially connecting into the ground plane here. And same thing with this capacitor, if I remember correctly. I'm basically telling you this without looking at the diagram, but ultimately that's what's going on, is it's going through that. But part of the circuitry, there is a little diode here that ties towards ground, or heads towards ground. And I think what its job is to make sure that the voltage from the negative 5 volt doesn't work its way back to the 5 volt. And because negative 5 versus 5 volt could cancel it out. And that could be what's going on, is it's just very briefly having a 5 volt supply, which would be enough to actually turn on this little LED, but then it collapses. And so my suspicion is that that little diode, and I'll show you a picture. It's really kind of hard for me to figure out exactly what that diode is. You know what, let me get my soldering iron out of the way, because I'm going to need that in a minute. Let me get it out of the way here. And I've got my voltmeter, and I actually have it on the diode setting because I was trying to test the diode. But, well, let me do it this way. I'm going to put it on ohms, and I'm actually going to try and test across. Now, I do not have a sound when I get continuity, so you'll have to watch and see. I got continuity there. Basically, remember, if I touch the leads together, I'm going to get 1.7 ohms, 1.6, somewhere in there. So now if I touch across the diode, I'm getting about the same, which means that it's conducting in that direction. Now if I switch the leads, it is also conducting in that direction. It should only conduct in one direction. So, based on that theory, if the diode is the problem, then the diode could be the solution. I need to try and get the diode off of here, which means I've got to actually find those two connections on the back. And I think I got it right there. Be these two here, which I can't really point out because I don't have a zoom functionality yet. I'm going to pull out the soldering iron and make sure I'm looking at that correctly. And I'm pretty sure it's these two connections. So I'm going to attempt to flow some new solder on there. And new solder on here. I need to heat it up enough. This stupid solder mask is really giving me issues with this thing. Now I gotta find my, there it is, my solder sucker, which I put away because it was getting in the way of other things. There's a lot going on lately. Well, let's see if we can't heat this up. Now, one of the problems in trying to figure this out, I actually tried to look up last night what this diode might be, but I can't see all the markings because it's actually soldered onto the board. So I'm going to have to remove this, hope that I don't totally screw it up. I mean, if the diode is still good, I'm going to test it out of circuit and see what happens with that. Oops, forgot to prime it. Well, we're going to get that nice and hot. That might actually toast the diode. It hasn't fallen out on its own. Now I need something to pry it up with. You know what? You just use the lead of the voltmeter. No, I didn't get enough of it out. Now I have the part. It's probably going to be a little on the warm side from the soldering iron. Boy, I mean, just to give you an idea, that's how small this thing really is. I'm going to have to take a magnifying glass as well as my reading glasses to try and read the part number. And the next time you hear from me, I will have some kind of answer. Thankfully, actually, there's a marking on the board also that tells me which direction the band goes. I could see this was a Motorola part, but Motorola has a limited supply of diodes they make. This device, I believe, goes back to 1991. So it would have to be something that was in their catalog back around then. But hopefully I can find a cross-reference that will tell me what kind of diode this is so I can figure out what a good equivalent would be. Oh yeah, that was the other thing, was I wanted to see, now that I have it off, I have my meter here, I can show you. I can set this on the diode setting, and if I do this right, it should tell me how much voltage it takes to make it conduct. And right now it's showing, I'm wondering if that's actually supposed to be 2 volts or 0.002 or 0.02. I need another diode for reference, but let me switch it in the other direction and we'll see. It's the same thing. I don't believe this is supposed to actually be giving me the same reading in both directions. I have a feeling this is actually a defective part. Okay, so now we have the part off. I have tested it, and it turns out that it's conducting in both directions. The diode test is showing the same voltage to make it conduct in both directions, which doesn't sound right to me. I think it should be only conducting in one direction. I mean, unless you apply ridiculously, you apply a high enough voltage, it'll conduct in any direction you want. Point is, these things, general diodes, general purpose diodes, will generally conduct at about 0.6 or 0.7 volts. This is coming up at what looks like 0.02 volts, basically meaning it's failed short circuit. It's as if somebody just put a piece of wire there, and that defeats the point of having the diode. So I'm going to look up the number. I'm going to figure out whether I've got a replacement here or whether I need to order a replacement or go pick one up locally. And then I will come back and we'll look at putting it on and testing it out and see if that fixes it. So that's it for now. Why do I have this compulsion to shove things into corners when I'm cleaning up? That's where I found my power supply. So you're going to find out at the same time I do whether or not this works. Now remember, the problem has been if I plug it in, I get a very brief pop of light out of that LED. And let's see what happens this time. Aww. I thought that might be it, but all right. We have the voltmeter tangled up on other things, but let's see if our voltages make any more sense now. And what we figured out over time, yeah, 20 volts should be good enough. We figured out that there is a ground pin right here that I can use as a reference, and I'm going to use that as a reference against the, now this should be common, so no, sorry, that's the input. So I'm getting 8.56. The common is giving me 5.5. Maybe I'm not reading this right. 4.99. Now that's almost dead bang on. So if I forget about the input, because something has changed, and it's probably that diode. I have a very low value. Well, I'm bouncing around 2 here. Now, if I remember right, the output goes to the ground on this one, so it should be there we go. I don't know why, but it's settled now at 5. I'm at -8 and change. That should be the input. And the output is giving me 0. Something really strange is going on. Okay, wait a minute. So on the 7905, if I remember right, it's ground, then input, then output. So if I put ground here, I have to be really careful I'm not shorting things out here. I'm getting 0.73 volts at the output. Negative, but okay, and I don't know why I'm getting 2.67 volts on the input. I'm just trying input versus output here out of curiosity. And that's about 2 volts. That's really odd. Let me try across the diode. We need 2.66 volts here. .66 volts the other direction. So something's causing that. Let's try, just out of curiosity, I'm going to go on the 7805 common and the input just to see what it's seeing. Oh, now that was interesting. That lit up the light. That's 3 volts. It's only seeing 3 volts at the input? If that's right, I'd be absolutely amazed that I'm getting 5 volts on the output. I'm having a real problem getting the probes on there. There we go. 0.5 volts. 3.5 volts, which kind of makes sense. Maybe. So here's my negative. Five and a half volts at ground. 8.45 at input. 5 volts dead bang on at the output. That's what I want. Now that 5 volts should be going right over here. There it is. That's the ground. Now the input should be, no, wait a minute, 5 volts. Yeah, positive 5 at ground. I'm getting negative 8. That's about a 13 volt swing, 13 plus. And it's a 13 volt supply. I've lost my ground connection here. And then 0 at the output. I'm wondering if that's actually, there's 0 volts between the output and ground. So something is shorting it to ground. Could it be that one of my capacitors is actually bad? All right, I'm gonna have to figure it out. Okay, well, I've been staring. I got a few more minutes, and I was staring at this and actually trying to create a good-looking schematic out of the diagram that I had written down. And I got to a certain point in the schematic where I was looking at, let me find something to point with here. Well, bottom line, I was looking at this voltage regulator here, and I'll bring it up for you, but it's the middle pin, and that middle pin is supposed to be ground, and it's supposed to be, according to what I can see, the trace on the board, it's supposed to be connected to a resistor and a Zener diode, which I just replaced. But as I was looking at it, and I took a picture and blew it up and looked at it really carefully, and I'm wondering if you can, I'm not sure if you're going to be able to see it too well. Yeah, I'm trying to see if you're even in frame here. Now you're in frame. Right towards the center of the picture there. That's the voltage regulator. And if I can angle it just right, you might, I don't know if there's going to be enough definition there to see, but it's not actually connected. It turns out that the trace that connects it to other things is on this side of the board, but there's no solder connecting it to the pad. It's mechanically connected at the back side of the board, but there's no trace on the back side. So I think what happened is when I took it off, I just didn't recognize the fact that there's supposed to be a little touch of solder there. And so I've heated up the soldering iron. We'll get out the solder here. And actually, the other thing I'm going to do is get my flux pen, because I want to be somewhat accurate about this. I'm going to flow some flux on there. This is kind of a cheapy pen, so it's not working all that well. I end up having to flood it with flux before I get what I want. Come on. I should probably buy a higher end pen. I didn't think it was going to become as important as it's becoming lately. There we go. Now I got a little bit, but like I said, I had to kind of flood it in there. I just want to get a little bit of flux in there to help me. And I'm hoping that what's going to happen is I'm going to do this very carefully. Try and get in and get some solder on this side. Now what I should have done is grab my magnifying glass. Coming back into the lab, but actually that kind of looks like it flowed some solder on there. So now if that's made a positive contact, then what I don't really, at this point I've gotten my hopes up so many times, my hope would be that I'm going to plug in and I'm going to see this green light come on and stay on. I don't think that's really going to happen, but let's find out together. Nope, it flashed on and off. Good thing I didn't get my hopes up. So I'm going to disconnect that. But now I've made that little connection. Let's grab the voltmeter. We've got it set on ohms. I'm going to put the two leads together to make sure. Should be about 2.1 ohms between. So what was happening was I was testing it and I was putting my probe on that middle pin and I was putting it on the top of the resistor and I was getting nothing. Now I'm getting something. So that means that it is now connected the way it should be. So that takes care of that problem. But this could just turn out to be one of those things where there's so many little things. Now keep in mind, I replaced the voltage regulators. So this could well be that's was part of the problem. Maybe I didn't need to replace the Zener diode. Maybe I still did. I think I still did. But I'm going to clean around there a little bit. I'm going to go back to it, and we're going to try and figure out what else is wrong. Okay, so I've been spending time going over this circuit. Again, still working on the circuit diagram. Well, actually, I pretty much got the power supply end of the circuit diagram worked out. And that was really where I figured the problem must be. But so far, everything I've fixed hasn't fixed it. So I'm not really fixing it. But as I'm going through the diagram and checking things, I noticed another little anomaly, which I'm going to try and fix. That is C12 right here. That has, if I flip the board over, it's going to be maybe a little hard to see, but essentially here's the two connections for that. And if you look closely, let me see if I can get it up closer to the camera. What you want to do is you want to look at this pin right here. Let me point it a little bit better there. If you look at that pin really carefully, you'll notice, I'm hoping I got that in shot, that you'll see that it's not actually connected to a trace on this side of the board. So I was trying to figure out, okay, that's probably part of the power supply because it's one of the bigger capacitors. What is it connected to? So if it's not connected to a trace on the back side of the board, it's got to be on the top side of the board. And so I started looking very carefully at this, and if I bring this up and it doesn't show, then I'll just take a picture and show you. But if we get up real close, let the camera focus. I'm hoping I got that in shot. Let's see. Yeah, I'm pretty sure I do. It's really hard to see, but you can't actually see where that pin connects. And I think what's happening is it's supposed to actually be soldered underneath the capacitor. And I'm not sure how I'm going to do that. But to test my theory, what I ended up doing was I ended up taking a jumper wire. Where did I put that? There's a jumper wire. Just a simple jumper wire with alligator clips. And since I think it's supposed to connect to the ground plane, I was able to connect to the ground plane on this pin. There's a test pin right here. And then I was able to flip the board over and touch it against that particular connection. Now what that does is it actually causes the light does not stay on, but when I remove it, the light goes on briefly and goes off again. So I'm not sure if that's the way it's supposed to be, and the only way to find out really is to explore by removing the brand new capacitor. So I'm hoping I don't somehow ruin the brand new capacitor, but I'm going to have to try to disconnect it. Now I've moved this all up onto a box. I'm hoping that the closer angle is a little bit better for you. Soldering iron should be warmed up at this point. Okay, I felt it come off. The pins are still intact, so that's a good thing. I already know which side is negative, and it's marked on the board too. So now let's take a look. Okay, this may be a little hard to demonstrate, and once I put it all back together in the video, I won't be able to take another picture of it. So I'm going to lift it up and show you. Oops, careful, don't lose that capacitor. I'm going to show you next to the regulator here. You can see the plus sign, and then look at the trace. I'm hoping that comes through, but that's where it's picking up a trace and going off. But it was the question was the negative side, and it looks to me like like maybe the negative is supposed to actually be connected to the ground plane here. I'm actually going to need to get a magnifying glass. It wouldn't make any sense to just put a capacitor there and have it float. So I'm going to go get a magnifying glass and we'll take a look. Okay, I'm back. I've got the magnifying glass. Put my glasses back on. And let us see. It's really kind of hard to tell. I think the intention was there's definitely a solder pad there. But what's weird is I've got this, it's hard to describe. Think of a square solder pad and think that the corners of that square are what are connecting to the ground plane here. So it's a little odd how it's done, but let's see. The holes are clear. It looks like it's plated through. What I really need is like a microscope to see it. But I think what I'm going to do is I'm going to flood that area with solder to get it through that particular hole. Then I'm going to use the other technique of getting, well actually wait a minute, it's connected on both sides on that too. So I should do both holes, and then I'm going to try and stick the capacitor in while heating it from the other side, and hopefully what will happen is it'll continue the plating and be able to connect on both sides of the board. I suspect that's what it is. It's just like a plating problem of some sort. I really can't tell for sure. I'm not the original designer, and I can't find an original schematic, so I've had to reverse engineer this to try and figure it out. But I'm going to go ahead and put some fresh solder in there. I'm going to put it on both holes. And then I'm going to flip it over. It's already worked its way through both sides. You know what? Let's just go for broke here. Because if it's connected, I mean, this could give me magic smoke and I'll be really disappointed after all of this, but Assuming it's electrically connected, let's see if it makes a difference. Well, light came on and went right back off again. Actually, it's not going on anymore. That's not good. All right. So I think what I'm left with is I've got to, this isn't working this way, so I'm going to have to go back to the old method of cleaning the hole. Well, let's try the other thing while we're waiting. Go ahead and plug her in and see if there's any difference. Oh, wow, now we're not getting a green light at all. That's discouraging. Wow. Some other component has gone bad on me. I don't know. Regulators are not super hot. I did have one that was getting kind of hot. All right. Let's, basically my new approach here is going to be, especially on this one here, to give it a fair amount of heat and solder and hope that will flow it down through. We'll just freshen up that connection there. There's a little dot of solder there. Let me get that off. The solder mask isn't doing me any favors either. I could have toasted the capacitor. I don't know. Now let's try plugging her in again. No green light. Oh, wait a minute. Did I see it just briefly? Wow. Toasty. I'm starting to wonder if I'm going to have to give up on this project. All right, let's see. Let's trace a couple of things just to see where we are. Actually, before I do that, we're still set on ohms. Let's find out if that capacitor got hooked up. Now, that test pin is right here. And would help if I had it turned on, wouldn't it? We have a connection that we didn't have before. That may actually be the problem. That's really interesting. I can't imagine that they would put a capacitor on there and just leave it to float. But we have the connection there now. I can test for another connection here. Make sure that got soldered on correctly. Yeah, that looks good. And there's another tiny little pin over here that side connects to. And now I've lost that connection. That's the connection on the other side of the board. So perhaps I actually need to heat this up to get the solder to flow through. And in fact, some of you are probably screaming at me going, why don't you use the flux pen? We'll get some flux on there, because flux helps solder to flow. It'll also raise a little bit of smoke, but that's okay. Okay, now that should in theory be connected to this pin over here. This little test, actually it's what they call a via. That's not so good. That means it's not making contact on the top of the board. Well, at this point, I may have cooked the capacitor. I'm going to try maybe flow a little fresh solder on there. See if I can get it to go through. When you have a pin going through it, it's a plated through hole. When there's no pin going through it, it's called a via. Basically, it's making a connection via the hole from the front to the back. No connection. Alright, let's see if there's anything else obvious. And that would have come up through that way, and I can't access it on the top. Or can I? Maybe that doesn't actually connect. I know. Jumper wire. I'll try to be careful with that, not short everything out. Of course, we're not even plugged in right now, so connect the jumper wire to one lead, and use the other lead to probe. This is where it's supposed to come through, and I'm getting nothing. A big nothing. So now the question is, what if I connect to that particular point? If I set up my jumper wire, I could run a bodge wire from here to there. So what I really need, this may be difficult to see. I'm going to go ahead and plug it in. We had no green light, but now if I make that connection to there, it should connect up to here. Yeah, I got the light to blink. So I don't know how well you're going to be able to see that. I'll put my finger next to it here. So something's causing it to shut down. So I can run a wire from here to there. That'll solve that problem. But I need to go back and figure out what else is wrong with this circuit. And I'll be honest with you, at this point, I have spent so much time on this that it's not really worth pursuing right now. So I think I'm going to end up putting this away. I apologize. I'm going to wrap up this part because it's a very long part too. I'm going to wrap it up here, and if you're really that interested and you want me really to get back to it, I'm going to unplug it before it overheats. If you really want me to get back to it, click the like button and leave a comment. The like button tells me that people are watching the video, and the comment will tell me what you're thinking. So, I guess that's it for now. Thanks for watching.